Okay to do a linear regression so far? Looks fairly linear. I mean, it's not like a total tight line, but it doesn't look bad. But what else do we check besides the linearity of the scatter plot? We got to check residuals too. And the residuals are in the residual list because we have run the linear regression. So let me just make a little, always copy my scatter plot down. Good enough. How do I graph residuals? Good. L2 goes to resid. If you've named other lists, then it won't be number 7. It's just alphabetical order kind of thing. You can name lists in your calculator if you like to keep lists hanging out. It's kind of a fun thing to do, to keep a bunch of lists hanging out. Okay. Let me look at my residuals. All right, what do I look for in my residuals? Scattered. Scattered. All right, so let me make a little sketch of my residuals. And we want them scattered. All right. So that's what we learned to do last fall. But now we're going to take our sample and do some inference with it. So let's move on to our newest procedure here. Yes? Oh, if you want the linear regression plot first, let me go back and change my plot to list 1, list 2. What just happened there? I don't know what happened. Try this again. Second 2. All right. And then the easiest way, there's a few ways to do this. Your regression equation is already there. But I find the easiest way to do this would just be to do my regression again. And go list 1, comma list 2, comma vars. Oh, I do? All right, I'll fix that. Vars, y vars, I'll put it in function number 1. Y1. List 1, comma list 2. Okay, thank you. There it is. Delete. And there's my, oops. Let me do a zoom 9 again. It didn't put it in there? I never pressed enter? Oh, okay. Oh, thank you. I never pressed enter. You're right. You are so right. And there it superimposes the regression line. Shh. Right? Okay. All right. Now we're going to think about the population least squares regression line. So, you know, as we did our inference for means and parameters, we had sample statistics. And they were like X bar and P. Okay? Our sample statistics for our regression line are going to be our y-intercept. That's A. Our slope. That's B. And our correlation, or we can do the coefficient of determination, whichever one we want. I'll just do correlation R. Y-intercept. Okay. The population parameters we're going to estimate are going to be the y-intercept. We're going to write that as a Greek letter. So we're going to write that as an alpha. Even though we already have something called alpha, we can have many things called alpha. Our slope, we're going to call beta, even though we've already got a beta. What's beta? But probability of type 2, yeah, but which is the complement of power. Okay? And the correlation, do you remember from that practice test what? Rho. Rho. Looks like kind of like a P. That's the Greek letter rho. Okay. So there are the population parameters that we can estimate on our least squares regression line. Our least squares regression line, oops, move it up. Our least squares regression line for the population is, oh, sorry, so it's the average of the population responses. Remember, responses are the y variables, such that the mean of those responses is the line alpha plus bx. Okay, so this may be what we're trying to predict from this population. We actually will just do one statistic at a time, but we could do all this. We could estimate all the population parameters via our statistics. So I have a mean of the y's of the responses and a standard deviation of the responses, a sigma. Okay. Yes, sir? Such that. Okay. So we'll deal with our null hypothesis and an alternative hypothesis tomorrow, because today we're going to check conditions for inference, because they're a lot harder than checking conditions for our other procedures. Yes. I'm going to show you that in just a second. So it kind of hard to see, but you'll see it here in just a second in a little drawing I'm going to go. And it's when I get down to condition number 3 that I'll show you what that standard deviation is. There's 4 conditions. First condition: all the responses, all the y's of the population, okay, are independent. Oh. So I need to go back and check what I'm doing here, what I'm measuring to check this condition. All right, so I've got this, what is it, fat gain? Yeah, fat gain. Oh, so is fat gain from person to person independent? Yeah. Sure. So I'm just going to, state that. Oh, I'm going to say this is condition number 1. Okay. Condition number 2. These are a pain. The population relationship is linear. Well, I don't know what the population relationship is. Sorry, that's a little crooked. All I know is my sample, so we're going to examine the scatter plot.